Hello, my group will explain about horizontal well test analysis. Before that, let me introduce my group members. My name is Wan Hasnur Rahman bin Muhammad Fauzi, and I will be explaining about the introduction of the horizontal well. Next is Muhammad Aizat bin Wahid, and he will be explaining about the basic flow regime. Siti Khalida binti Abdul Hamid, and she will deliver about the pressure behavior and the equation of flow pressure equation. And lastly is Khairul bin Anwar, who will give an example and conclude this topic. Horizontal wells have been extremely popular since 1980s. The traditional methods of extracting oil are being replaced by this method that allow more control and precision, increasing oil production and decreasing environmental impact. First, a wellbore is drilled vertically into the shale thousands of feet below the surface. The drilling process then makes approximately 90 degrees turn into the shale formation and extend the wellbore horizontally. This technique vastly increases the productivity of natural gas extraction. Horizontal drilling offers many advantages compared to the vertical drilling. This technique comes with numerous benefits to the environment and economy at a global scale. First of all, it can drill a number of wells. Using horizontal drilling technique, company cannot drill a number of wells in different directions from one well pad, which is much more efficient than having numerous well pads set up to extract oil. This decreases the surface disturbance and save money with the reduced cost of well pad setup, replacement and maintenance costs. Second, horizontal drilling also have a greater production rate than traditional vertical drilling because of the greater wellbore length exposed to the pay zone. Oil companies tap into this new area of oil by going in at angle into a reservoir, which is difficult or impossible for vertical drilling. Possibly the greatest benefit of all is the ability to locate well site away from the residential area and sensitive ecosystem. Oil companies today can access oil and gas by drilling a well that is miles away from a specific property or site. However, there are few problems in horizontal well analysis. Factors that complicate horizontal well test interpretation is non-uniform skin effect along the wellbore, selective completion along the horizontal well, and the heterogeneities in vertical direction as well as lateral direction.
Hello, my name is Muhammad Aizat bin Wahid. Previously, Hasnul has given a short briefing about history of horizontal well testing. Now, I would like to continue the basic flow regimes in horizontal well testing. Basically, basic flow regime is divided into three parts, which is radial flow, which happen in early time. The second is linear flow, occurs in intermediate time. Then pseudo-radial flow, which occurs in late time. Let's see a clear overview about basic flow regime. Before that, I would like to express the vertical is the z-axis, while the left hand side is y-axis and the right hand side is x-axis. The first one is radial flow, which happen in vertical YZ plane. As you can see here, it is said to be radial flow because the flow occurs around this plane. On the other hand, only at this time the true skin can be measured. The second is linear flow that happen in intermediate time. It happen around the Y plane. It is because if the well is long compared to the reservoir thickness, these parts or situation will occur because pressure transient reaches the reservoir boundaries. In addition, it will not happen in well with pressure maintained by 1. Gas cap and aquifer. Last but not least, pseudo-radial flow, which happen in vertical XY plane. Through the horizontal well testing, the apparent skin can be determined, which give the information about well bore damage and additional pressure drop. After this, Khalida will explain a further explanation about basic flow regime. Thank you.
Hi guys, let us understand the pressure behavior of the horizontal well. The pressure behavior of the horizontal well is usually interpreted by using one log graph of pressure and derivative of pressure over time. The first part is where the well bore storage effect takes place. Well bore storage effect occurs during the initial time of production. Well bore storage is more prominent in the horizontal well compared to vertical well, as there is more fluid in the well bore in the horizontal orientation. Next is early time pseudo-radial flow. Stabilization of the pressure takes place during the early time region. This is the lowest pressure region inside the system. Since the well bore storage effect has masked the fluid flow during this time region. Next is the intermediate time linear flow. The pressure increases as the fluid flows further from the well bore. The slope shows a linear straight line, giving us a hint that linear flow regime takes place. Last but not least is the late time pseudo-radial flow. Stabilization of the pressure takes place again as it has moved further away from the well bore during this time region. Stabilization of pressure during the late time region is higher than the stabilization of pressure during the early time region. This is because the well bore storage effect has masked the fluid flow during this early time.
What about the horizontal well equation? The horizontal well equation is determined using zone aberration testing concept. The equation is developed based on horizontal well behavior such as early radial flow, intermediate linear flow, and late radial flow. It is known the pressure equation is based on the basic equation of single flow rate vertical well equation. Now, let's move to the first equation, which is the early radial pressure equation. Since the well is a horizontal well, the contact area of the well changes. The vertical well is affected by the height, whereas the horizontal well is affected by the length of wellbore penetration. The wellbore penetration is parallel to the reservoir bedding. In the early stage of production, the fluid inside the reservoir flow in the vertical flow regime, as shown as in the figure. Thus, it is assumed the permeability is equal to the square root of vertical permeability multiplied with horizontal permeability, and h is changed to the length of wellbore. By substituting this new variable into original equation, we will obtain the new equation. Not only that, the apparent skin and the mechanical skin equation are also affected by the variable changes. For intermediate linear flow pressure equation, the change pressure equation is affected by different parameters due to the increase of development of fluid flow radius in the reservoir. The last equation of the horizontal equation is the late radial flow pressure equation. After long production process, the area of fluid flow reached significant distance. The fluid flow started to flow in horizontal manner, and thus we can assume the permeability is equal to horizontal permeability, and we substitute into the original equation. Not only that, the apparent skin and the mechanical skin is also affected by the changes of the parameter.